Have you ever heard about the famous Bermuda Triangle? Well, it is a mysterious triangle. It is a loosely defined region in the western part of the North Atlantic Ocean. The places that it connects being Florida, Bermuda, and Puerto Rico. Now, the authorities want to know how much area does this Bermuda Triangle cover. Why? Because the ships that pass through this triangle get disappeared. Actually, they disappear in mysterious circumstances and no traces of them are to be found. Not only ships but even aircrafts passing over this region, they also disappear. So the authorities, they want to know how much area this covers so they can be sure that no aircrafts or ships go from this region. So for that, they all need to know how to find the area of a triangle when three vertices are given. Now here we'll use coordinates instead of these vertices. So let's see how to find the area of a triangle when we know about the three coordinates. Here you can see that we've created a triangle ABC with the coordinates x1, y1, x2, y2 and x3, y3 respectively. Now we have these two axes, x-axis and the y-axis. Now let us construct perpendiculars from B, A and C towards the x-axis so that they meet the points Q, P and R respectively. Like this. You can see we have constructed perpendiculars. So this line joins B and this point Q. The blue line joins A and the point P. And the green line here joins the point C and the point R. Now we know about the coordinates of B, A and C. Now let us write down the coordinates of Q, P and R. What will be the coordinates of Q? Well, you can see that Q and B lie on the same vertical line. So it will have the same x coordinate. Now what will be the y coordinate of Q? Will it be same as B? Y2? No. Q is a point that lies on the x-axis. Now any point that lies on the x-axis has the y coordinate as 0. So the y coordinate of Q will be 0. Now find out the coordinates of P and R yourself. Well, P will have the same x coordinate as A because this line joins both A and P. So both will have the same x coordinate. What about the y coordinate? Now P again lies on the x-axis. So the y coordinate will be 0. Similarly, let's write down the coordinates of R. It will have the same x coordinate as C because this is a vertical line joining both C and R. Now this R also lies on the x-axis, so y coordinate will be 0. Now we've written the coordinates of Q, P and R. Now let us find out the distance between B and Q, A and P and C and R. Now what will be the distance between B and Q? Well, we know that whenever the x coordinates of two points are same, to find out their distance, we can just subtract their y coordinates. So here we can subtract their y coordinates, y2 minus 0 or 0 minus y2. So what we'll get? y2 minus 0 as y2. So the distance between B and Q will be y2. Similarly, the distance between A and P can be found out. Do it. You can see that the distance between A and P will be what? Both are having the same x coordinates, x1, x1. So to find out the distance between them, we have to subtract their y coordinates. So y1 minus 0 will give us y1. Similarly, find out the distance between C and R. Both have the same x coordinates, x3. So to find out their distance, we can calculate it by y3 minus 0, subtracting the y coordinates. So y3 minus 0 gives us y3. So we found out these distances. Now let us find out the distance between QP, PR and QR. So how will we find out the distance between QP? Just like we found out the distance between BQ, AP and CR? You can see that the coordinates Q and P are having the same y coordinate. So to find out their distance, what we can do is subtract their x coordinates. So to find out QP, we'll subtract their x coordinates. We'll write x1 minus x2. Now let us find out the distance between P and R. Again, both are having the same y coordinates. So we have to subtract their x coordinates. So subtracting their x coordinates will give us x3 minus x1. So this is the distance between P and R. Now we have to find out the distance between Q and R. You can see this is Q and this is R. So how will you find the distance between Q and R? See, both are having the same y coordinates. So we have to find out the distance by subtracting their x coordinates. So subtracting their x coordinates will give us what? x3 minus x2. So we have found out the distance between QP, PR and QR also. So we have written down whatever information we have already taken out. Now what we have to find out is area of triangle ABC. So we have to find out the area of this triangle. But we cannot find out the area of this triangle directly. What we'll do is, we will find out the area of trapezium ABQP. Now which is this trapezium I am talking about? A, B, Q and P. This trapezium. Now first, area of triangle ABC is equal to area of this trapezium plus area of trapezium APRC. A, P, R, C. So area of triangle ABC is what? Area of this trapezium plus area of this trapezium. But what do you see? After adding this and this, don't we have something extra other than triangle ABC? Yes, we are having this part extra. We do not need this part. So we need to subtract from this extra part. So we can say that if we subtract area of trapezium RCBQ, if we subtract this part from the whole thing, what will be left is the area of triangle ABC. So now let us find out the area of these trapeziums. Let's have a quick recap. Area of a trapezium is half into sum of parallel sides into perpendicular distance between the parallel sides. So now using this formula, we'll find out the area of these trapeziums. Now first let us find out the area of trapezium ABQP. This is what? Half into sum of parallel sides. So what are the parallel sides of trapezium ABQP? A, B, Q, P. Look at this. These are the parallel sides. So we'll write sum of parallel sides here. BQ plus AP. Into, what do we do? Perpendicular distance between the two parallel sides. So the perpendicular distance here is QP. So this is the area of trapezium ABQP plus area of trapezium APRC. Look at APRC. This is APRC. Now, these are the two parallel sides. So we get half into sum of parallel sides, that is AP and CR. So AP plus CR into the perpendicular distance between these parallel sides, that is PR. into PR minus area of trapezium RCBQ. Look at the trapezium RCBQ. Well, you can see that the parallel sides are BQ and CR. So we'll write half into BQ plus CR into the perpendicular distance. Now what is the perpendicular distance? QR. So this is how we calculate the area of these trapeziums. Now instead of using BQ, AP, QP, CR, PR, we can use their substitutions. That is, we can use that values that we have already found out. So let us use these values instead of these sides. So let us write it down. Half into, substitute BQ, that is Y2, plus AP, that is Y1, into QP, that is X1 minus X2, plus area of the second trapezium, half into AP, that is Y1, plus CR, that is Y3, into PR, that is X3 minus X1, minus half into BQ, that is Y2, plus CR, that is Y3, into QR, that is X3 minus X2. So we have successfully substituted all these values instead of these sides. Now we have to solve this. Now this will be a long equation. Let's solve this. Now we've written that equation here. Now we'll solve this out. What we'll get? Half. Now we have to multiply these two brackets. So Y2 into X1 will give us Y2 X1. Y2 into minus X2 minus Y2 X2 plus Y1 X1 minus Y1 X2 Now what we've done, we'll do that, we'll take out the half common in all the three. So taking out common, we have written this half outside. Now what we'll solve is these inside parts together. Now plus solving this part. Y1 into X3 we get Y1 X3. Y1 into minus X1 minus Y1 X1. Y3 into X3 Y3 X3 and Y3 into minus X1. So minus Y3 X1. Now we'll solve this part. So we have the sign minus here. Y2 into X3 Y2 X3. Y2 into minus X2 minus Y2 X2. Y3 into X3 plus Y3 X3 and plus Y3 minus X2. So minus Y3 X2. We've done this. Now we have to solve this equation by opening the brackets, taking half common from all. What do we get? Y2 X1 minus Y2 X2 plus Y1 X1 minus Y1 X2 plus Y1 X3 minus Y1 X1 plus Y3 X3 minus y3x1. Now we open this bracket also. So we have this sign minus here. So minus y2 x3 minus minus plus y2 x2 minus plus minus y3 x3 and minus minus plus y3 x2. Now let's see whether we can cancel anything. Here you can see we can cancel plus y1 x1 and minus y1 x1. What more can we cancel? Plus y3 x3 minus y3 x3. What more can we cancel? Minus y2 x2 and plus y2 x2. Well, this is all we can cancel. Now let's try to take common whatever we are having it here. So we get half common. Inside we can take common as from these two we'll take x1 common. So what do we get? x1 out. y2 minus y3. Then we take this and this. You can see both is having x2 common. So plus x2. y3 minus y1. Now what are we left with? We are left with y1 x3 and y2 x3. So we'll take x3 common. So plus x3. We get y1 minus y2. So we have formed an equation that gives us x1, y2, y3, x2 and y2 separately in this equation. So this is what we get. So you know, whenever we have to find the area of any triangle of whose three coordinates are given, we can say that the area of the triangle ABC will be half into x1 brackets y2 minus y3 plus x2 brackets y3 minus y1 plus x3 brackets y1 minus y2. So we can substitute the coordinates instead of this formula and find out the answer. So now we had started with this Bermuda Triangle. Now let us find out the area of this Bermuda Triangle. Let me give you the coordinates of these three vertices. Now the vertices are A, B and C with the coordinates 4, 3, 8, 0 and 8, 6 respectively. So we have written the vertices for you. Now to find out the area of a triangle, we use this formula. Now using this formula, can you find out the area of this Bermuda Triangle? Do it yourself. Now to make our work easy, let us name these coordinates as x1, y1, x2, y2 and x3, y3. So what we'll do? We'll just put down these values in this formula and solve. Half brackets x1 that is 4, y2 that is 0 minus y3 that is 6 plus x2 that is 8 brackets y3 that is 6 minus y1 that is 3 plus x3 that is 8 brackets y1 that is 3 minus y2 that is 0. And we close the bracket. Now solving it further, we get half 4 into 0 minus 6 that is minus 6 into 4 minus 24 plus 8 into 6 minus 3. 6 minus 3 gives us 3. So 8 into 3 that is 24 plus 8 into 3 minus 0. Now 3 minus 0 is 3. So 8 into 3 gives us 24 again. Now you can see we have minus 24 and plus 24. So we cancel that. What do we get? Half into 24. Now cancelling this, we get 12 square units. Why square units? Because we are finding out the area of the triangle. Well, the area of the Bermuda Triangle is 500,000 square miles. So you can see that we hadn't taken the scale here. So we got 12 square units, but the area of the Bermuda Triangle is actually 500,000 square miles.